In this section, we are going to look at the first permissioned blockchain called as Hyperledger. Right? We'll talk about the transaction flow of Hyperledger to understand how this permissioned blockchain space differs from the permissionless blockchain in terms of executing the transactions. Right? If you go to hyperledger.org, you can find that this Hyperledger project is an open source project by Linux Foundation. There are multiple organizations involved in contributing to this open source project, and they all make use of this framework to build permissioned blockchains for themselves and their clients. For example, IBM, Accenture, Goldman Sachs, these are a few companies which contribute to the code of Hyperledger itself. Right? Now, to compare and contrast between the permissionless space and the permissioned space of this blockchain, we need to look at how in general transaction works in Ethereum and how it works in Hyperledger. Okay. Now, before that, an analogy, right, is that when you want to apply for a leave in your company, what do? You send a mail to your manager first, and he will say, okay, you're approved to take that leave. Then you will send a mail to your VP, and he will also tell you that it is approved. Then you submit it in the system with both the approvals. This will go to the HR and that will be executed, right? You will get your leave. So this is the rules set by the organization saying, okay, if you want to take leave, before submitting the leave request onto the system, you have to get approval from your manager and VP, right? So that is how this transaction works, and that's exactly how Hyperledger also works inside, right? Before getting into understanding more about, okay, what is this Hyperledger transaction flow and everything, let me show you how in general it works in permissionless blockchains. Okay, when you look at permissionless blockchain like Bitcoin, Ethereum, anything, right, you will see that you will first order the transactions. What is this ordering of the transactions? Miner picks all the transactions from the transaction pool and he orders them in the block, right? Then he will do the mining process and everything, but first comes ordering, right? Then he will execute the transaction. This is where the money transfer happens. Then while he gives the block to the other nodes, they will validate the block and the transactions and add that block to their blockchain, right? So you can call it probably OEV model, correct? Now, our guy, Hyperledger, does not use this, but he goes for a execute, order and then validate kind of a model, where execute comes first, order comes second, and then comes validate. Why is that? We are going to see now, right? What happens is the submitting client, okay, this employee who wants to do a transaction. Remember, this is a permissioned blockchain. Everybody in the network knows who this employee is. Okay, he cannot just privately or anonymously submit any transaction. So this person submits a leave request, right? Transaction proposal goes to peer 1, who is your manager, let's say, and peer n, who is your VP, let's say. Peer n can be seen as peer 2. Okay. So these people, what they will do is, they will look at, okay, if he takes leave, what will happen? Do we have a replacement and all of that? And they will provide a, okay, after this transaction simulation, this is where they think, okay, will this be okay? Is the input giving the right output? Do we have backup for him? Can he take the leave? Does he have enough leaves? And all of these things they will see, right? Both of these people, they are going to endorse the transaction. Okay, endorsement is the approval that they give, right? In Hyperledger world, we call it endorsement. Okay, so they are gonna give back the mail saying, okay, your transaction has been endorsed by us, right? Once this client gets back the endorsed signature, right, so he will submit the transaction to this ordering service. This is like the HR in our example. Okay, so broadcast endorsement is the step where he submits the transaction to the ordering service. Okay, HR, just like it gets this leave request from one employee, gets multiple leave requests from other employees also, right? This HR will add that to the block, okay, into a new block, and they will transact to all the peers, transaction delivery to all the peers in the network, right? What is this? All the peers, the other peers, this leave request transaction only happened between one node, which is the employee, another node, which is the manager, another node, which is the VP, and the HR, right? Four. But there might be 3,000, 5,000 employees also in that organization. So everyone gets the transaction because it's a decentralized network. Every node has to have a copy of the entire blockchain. Same concepts apply in permissioned also, right? This happens. One thing to note is that this verification of the policy that is done by the HR says, okay, as soon as they receive the leave request, right, they will see, has he got the approval from his manager, has he got the approval from his VP, right, which means they will check the endorsement signature. If it is working, if it is matching according to the company rules, only then it goes into this block itself, right? Same thing will be checked by all the peers in the organization also, right? That is the validation part. Okay, that's why I say first the order is, or the transaction is executed, this portion, right? Here is when the transaction is executed first. Okay, then it goes to the orderer. Okay, this is in fact called as ordering service or orderer. Okay, orderer. These are called as endorsers or endorsement peers. Okay, endorsers, orderers, right, in Hyperledger. Okay, so this ordering service creates the block. In Ethereum, first the block is created, then only executed, right? Here it is executed by these people and then only ordered. Okay, and then when these peers get the block, they will validate, okay, whether the block is proper or not. That's why we call it the EOV model. Remember, very important in Hyperledger. Okay, so this is exactly how permissioned blockchain works, and why they all follow this execute, order, and validate model is because probably for the entire company which has 5,000 nodes, right, there will be only one orderer. Okay, when there is only one orderer, typically only one orderer in the entire network, right? So the orderer cannot be bombarded with a lot of requests. It will actually not have the capacity to execute all of that. Yeah, and that's the reason it might fail. So that's why we see, okay, let's reduce the heavy load given to the orderer, right? They don't need to execute all of that. Yeah, they will be executed first, then it will go to them. Okay, whichever is not getting the endorsement signature, whichever employee is not getting the leave, right, they won't be sent to the orderer itself. That way we reduce the workload of the orderer. Okay, so if the workload increases for the orderer, right, that becomes a bottleneck for your entire organization. You don't want that to happen. Yeah, that's why probably we follow execute, order, and validate kind of a situation here. That's the transaction flow in Hyperledger. Hope you got a gist of what this permissioned blockchains look like and do and everything. Most of the concepts like validating it, distributed network, multiple nodes, and everything remains the same, right? But one thing to consider is there is no cryptocurrency in the permissioned blockchain. Okay, in Bitcoin and Ethereum we have a cryptocurrency because we have to reward the miner, yeah, for doing that work, because it's a permissionless blockchain. They can volunteer to be people. But in this case, in a permissioned blockchain kind of space, right, the employees are the people who are writing transactions. You don't need to reward your employees. You're already giving them salaries and everything, right? So there is no crypto. There is no difficult consensus mechanism. Okay, as in proof of work is not there in permissioned blockchain. Instead, they follow some other consensus mechanisms like, these endorsement, whatever you say, right? Endorsement policy, as we call it. Here, the policy was you have to get a sign from both your manager and VP, right? So this person and this person has to sign. Only then your transaction will be validated. That's your endorsement policy. That's what takes care of the consensus. Okay, consensus is there, but proof of work is not there in a permissioned blockchain. Okay, scalability, you can say it does somewhere around 400 transactions per second, as opposed to Bitcoin which does 7 and Ethereum which does 15 to 19, right? This does 400 transactions per second, which is pretty good compared to the standards that the permissionless blockchains have. Yeah, so these are the concepts that you need to keep in mind before we move into applications and use cases of this blockchain technology. I hope this gave a very good understanding for you in terms of permissioned blockchain. If the transaction flow of Bitcoin, Ethereum, and Hyperledger is not up to the mark to you, right? If you're not understanding any one part of this transaction flows, please go back and revise the concepts, because it becomes very important, right? Next, we'll look at the use cases in the next section.